Hello, my name is Fausto Vega, and this summer I participated in the Robotics Institute of Summer Scholars Program at Carnegie Mellon University. The project title is Effective Collision Avoidance for Unmanned Aerial Vehicles. This summer I had the opportunity to work at the Air Lab under the direction of Dr. Sebastian Scher and PhD student Mohamed Mosai. The project focus was to simulate a state-of-the-art collision avoidance system called ACAS SXU on the X-Plane 11 flight simulator. Also, to investigate and test the control barrier function method of collision avoidance and compare it to ACAS SXU. So, quick background on the current methods, which is TCAS. TCAS is a global standard to ensure safety among all aircrafts. TCAS stands for Traffic Alert and Collision Avoidance System, and it increases the cockpit awareness and prevents mid-air collisions. It does this by transponders that are on board the aircraft that publish their current position, which display on the pilot screen as shown on the right. Yet the issue with the current system is that it is an invasive method of collision avoidance that sends notifications when not necessary, which can result in collision. So this has led to current research in airborne collision avoidance for manned and unmanned aerial vehicles called ACAS SXU. This is an alerting and guidance system that's a computational method for producing an optimized decision logic for the aircraft. The current method that we are using is ACAS SXU, which is meant for smaller UAVs. What the ACAS SXU logic does is that it generates a surveillance and tracking module, which detects the aircraft and tracks the position, along with the threat resolution module, which identifies the aircraft threats and resolution guidance. So the methods taken to simulate this on the X-Plane 11 flight simulator are to use the X-Plane Connect plugin to communicate with X-Plane 11 in order to gather all the states of both the own ship and the AI aircraft that will be spawned. By states, I mean velocities, altitudes, and latitude and longitude of the aircraft. Once all these states are gathered, it is published via ROS onto the ACAS X. And once ACAS X receives this information, it'll generate the threat resolution module report. And if a threat is found, send a message back to X-Plane 11 to control the surfaces of the aircraft to avoid this collision. So this is a quick video of an AI aircraft spawned in front of the own ship. The TRM report generates a vertical advisory to decline down, and the next steps are to command the control surfaces of the aircraft in order to avoid the collision on the X-Plane 11 simulator. The next part of the project focused on control barrier functions, which are a method that imposes safety constraints of the trajectory of an aircraft in order to ensure safety. It is a predefined safe set, which is the set of all safe states of the aircraft, and a specific function h is defined, which maps n-dimensional state space to one value, which is the notion of safety. And as long as h is positive, it means that the aircraft is safe. And this safety restriction is checked throughout the entire length of the experiment in order to ensure the safety of the aircraft. So the methods that I took are to use an existing repository that my mentor created and try to validate it on a drone platform to see if the results matched. And this is shown in the video that's playing right now. So my approach was to create a drone with a Raspberry Pi 4, an Intel T265 to localize indoors, and a Pixhawk autopilot in order to receive position information. So on the right is the control barrier function simulation, and I'm taking the robot position from that simulation and publishing to the set point topic that Mavros expects on the drone, and the drone follows this waypoints as the drone is switched to off-board mode. So a quick acknowledgement to the Robotics Institute of Summer Scholars Program for this amazing opportunity, as well as Mobility 21 for funding this experience, along with the Air Lab for providing the guidance and direction for this project. Thank you.